Hi, welcome to lesson 5.2. The objective here is we're going to graph the quadratic functions that we were talking about in the first lesson and then find maximum and minimum values. That's just part of graphing anyway. So the properties of a graph of a quadratic in standard form is the first thing we're going to look at before we actually start graphing. Standard form is what you see right here, where it's ax squared plus bx plus c. Right. When a is greater than 0, so positive, the parabola opens up. That's kind of like the ones we were looking at for the most part in the first lesson. When a is less than 0, it opens down. This example here is one where the a would be negative and it's opening down. The axis of symmetry line is x equals the opposite of b over 2a, where b is the coefficient of the linear term, a is the coefficient of the quadratic term. So that formula you can use every time to get the axis of symmetry. When you have the axis of symmetry, remember we talked about in the first lesson that the x-coordinate of the vertex is always going to be the same as the axis of symmetry. So because the vertex touches the axis of symmetry. So the opposite of b over 2a is also the x-coordinate of the vertex. In order to get the y-coordinate of the vertex, it's the value of y when x equals the opposite of b over 2a. In other words, you're going to find f of the opposite of b over 2a. That's just a fancy way of saying you have the equation, you substitute whatever that number is. So let's say it's 3, right? You substitute 3 into the function, whatever you get out, that's the y-coordinate. Now you have the ordered pair for the vertex, and you can graph it. The y-intercept is 0c. So whatever the value of c is the y-intercept. So using those properties, we can set up a system where we can graph, right? So the first thing you're going to find and graph the axis of symmetry. The second thing is then you're going to find and graph the vertex. Then you're going to find and graph the y-intercept and its reflection. Remember we talked about how in the first lesson that there's points that correspond, right? So if you know one point, y-intercept, you can get the point that corresponds to it as well. Then you're going to find one other point by evaluating the function for x and then graphing its reflection point as well. Once you have all those points, you can then sketch the curve. All right, so let's put those 5 steps into action in example 1. So the first thing I'm going to do is find the axis of symmetry. Remember, we just defined that as the opposite of b over 2a, where x equals that, to be specific. Well, in this case, your a is the coefficient of the quadratic term, which is -1. Your b is the coefficient of the linear term, which is 4. And your c value is 2. So if I'm finding the axis of symmetry, b is 4, so the opposite of that would be -4. And then a is -1, so 2 times that is going to end up being -2. When you reduce, you get 2. So the axis of symmetry is at x equals 2. I'm going to go ahead and draw a dashed line. I'm doing a dashed line because it's not actually part of the function, right? It's just something that we can use to help draw the function. So I'm not going to draw a solid line. I'm going to draw a dashed line to indicate that it's not actually part of the function. And I'm even going to change colors when I go and actually graph the function, just so we can tell that it's not the same thing. So for the vertex, I already have half the vertex. The x-coordinate is 2. In order to get the y-coordinate, we're going to substitute 2 in for x in the function and simplify. So keep in mind that negative sign, when it's part of the function, is separate from x. So my square x, I'm squaring the two separate, and then the negative will be applied as multiplication after that. So 2 squared is 4, that negative makes it negative 4. 4 times 2 is 8, and then that plus 2 is just plus 2. Negative 4 plus 8 is 4, plus 2 is 6. So the ordered pair, now I know the y, when x is 2, the y is 6. So I can plot that point now. So up 6 would be right at the top of this particular graph. Okay. The other thing we learned, or another thing we learned, is that the y-intercept is just the c value. So the ordered pair 0, 2 is going to be the y-intercept of our graph. So this one goes right here. The point corresponding is on the other side equidistant. So if it's 2 units away from the axis of symmetry, you go 2 units on the other side and plot a point. Okay. Now you get to the part where you just pick something else. So you pick a value of x that you think is going to fit on the graph. If I already know that the vertex has an x-coordinate of 2, the y-intercept has a x-coordinate of 0, I'm going to pick the x value of 1. I'm going to find out where's the point in between here. So when x equals 1, I'm going to substitute 1 into the function. Just do the same thing I did in that other step. And evaluate. 1 squared is 1, multiplied by a negative 1 makes it negative 1. 4 times 1 is 4, plus 2. Negative 1 plus 4 is 3, plus 2 is 5. So your ordered pair is 1. So when I plot that point, it's here. I get its reflection. It goes here. And the last step is just draw a curve through those points. The only other thing I'm going to point out is this is opening down, and we could have known that, or I could have pointed that out ahead of time, because the a value is negative. If that a value was positive, this would have opened up. Let's take a look at the next one. At this point, I might suggest pausing it, trying all the steps yourself, and then coming back and seeing if you got all the steps. All right, so let me go through the steps with you here. Axis of symmetry is x equals opposite of b to a. In this case, b is 1 and a is 1/2. So you end up with negative 1 over 2 times 1/2, which is 1, so negative 1. So your axis of symmetry is at negative 1. I'm going to do a dashed line there. We already know that the x-coordinate of the vertex is at negative 1. Let's substitute negative 1 into the function, get the y value. Negative 1 squared is 1, times the half is 1/2. Negative 1 is negative, so it's minus 1 there, and then plus 3. So 1/2 minus 1 is negative 1/2. Negative 1/2 plus 3 is 2.5. So I'm just going to think about it as 2.5. So the vertex is at negative 1, 2.5. So okay, that's a decimal. If I go left 1 and up 1, 2.5, I'm right here. Okay. Now let's find the y-intercepts. Remember that is given as whatever the c value is. So that's simple, just pulling that number out. So 0, 3 is the y-intercept. So I can plot 0, 3, should be right here. And then its reflection point would be right here. Now I just need one other point. In the last example, we could pick something in between. Here, there's nothing. I mean, you could, I suppose, pick -1/2, but I'm not going to choose a fraction if I don't have to. So my next option would be to go 1 to the right. So I'm going to pick an x value of 1 and see what's the y value on this side. It's probably somewhere up here. So y equals 1 is, I'm sorry, x equals 1 is what I'm choosing. And I'm going to substitute that in and solve for y. So y is equal to 1/2 times 1 squared plus 1 plus 3. 1 squared is 1 times 1/2 is 1/2. 1 is 1, 3 is 3. So 1/2 plus 1 is 1.5 plus 3 is 4.5. So let's just make it 4.5. The ordered pair is 1, 4.5. So that means I go right 1, up 4.5. So it looks like that would be right about here. It would reflect to here. And I can now just do the last step of sketching the curve through. Okay. Let's look at the next one. This is just a little different because if you notice there is no b value. So the a value is 2. There is no b value, so it's as if the b is equal to 0, right? And the c is the last one. So sometimes people, when they see something like this, will just assume it's a and b. Well, if there is no linear term, then you skip the b and the constant is still c. All right, so your a value is 2, your b is 0, your c is -4. All the same steps will apply. So the axis of symmetry is still the opposite of b over 2a. B is 0, so you end up with 0 over 2 times a, which is 2, but it doesn't matter because 0 divided by 4 or 0 divided by any number is going to be 0. So your axis of symmetry is the y-axis. When you find your vertex, x equals 0, we're going to substitute 0 into the function, and we get y equals 2 times 0 squared minus 4. 0 squared is 0 times 2 is 0, so you end up with 0 minus 4, which is -4. So your vertex is at 0, -4. So right here. This impacts the process in just one way, in that the c value is -4. So the y-intercept is -4, which happens to be the vertex in this case. So you're not going to plot that again. We just need to find something else now. So we're just going to go 1 point to the right, x equals 1. Substitute it in, you get y equals 2 times 1 squared minus 4. 1 squared is 1 times 2 is 2, minus 4 is -2. So the ordered pair is 1, -2. So I can plot that. Right 1 down 2 is here, reflects to here. That's pretty much the same as the fourth step typically, right? Was need to repeat that step because we didn't get a point out of finding the y-intercept because it overlapped with the vertex. I mean, it was the vertex. So now I'm just going to do 1, 1. So x equals 2. Substitute 2 in, you get y equal 2 times 2 squared minus 4. 2 squared is 4 times 2 is 8. Minus 4 is 4. So the ordered pair would be 2, 4. If I plot the point 2, 4, I go right 2, I go up 4, and I get a point there. It would reflect to there, and now I can draw my curve just the same. So that's how you're going to handle if the function looks a little different, where there's no linear term. Basically the same process, it's just that, again, you're not going to be able to get a point out of the y-intercept because you already had it with the vertex. So you just basically repeat step 4. You do that step twice. All right, I'm going to leave this question as the exit ticket. So I'll leave this one here. You can try that one on your own. And then I'll set this up as an exit ticket as a separate link in Google Classroom. And then this part of the notes is really just talking about what I just explained, right? Since there is no linear term, the axis symmetry is on the y-axis, it's the y-intercept. So you need to do that other step twice. The y-coordinate of the vertex of a parabola represents the maximum or the minimum of a quadratic function. This was the second part of the objective. So where it says graph the function, find the maximum or minimum value of the function, you can answer this once you know the vertex. And it's going to be one or the other. It's not going to be both. So the first thing we're going to do is find the vertex. We'll find the axis symmetry, I guess, technically. So same process, right? Opposite of b is 8. So the opposite of that would be negative 8. And then a is 2. 2 times 2. So denominators, you have negative 8, 4, which reduces to negative 2. All right, so you've got your axis of symmetry going through negative 2. We're going to find the vertex, the y-coordinate of the vertex. Same way, we're going to substitute that negative 2 in for x. So y is equal to 2 times negative 2 squared plus 8 times negative 2 minus 1. Negative 2 squared is negative 4 times 2 is negative 8. Positive 8. 8 times negative 2 is negative 16, and then minus 1. 8 minus 16 is negative 8, minus 1 is negative 9. So your ordered pair is at negative 2, negative 9. The process for graphing the rest of this function is just the same as we've done, so I'm not going to repeat that here. But the vertex is at negative 2, negative 9, and that's the answer to this question. This one is going to open up. And I know it's opening up because A is positive. So because it's opening up, and that's the vertex, oh, it's also at negative 9. All right, hold on. The vertex is at negative 9, so it should have been down here, right? So 2, 4, 6, 8, 9, like down here. It's going to open up, which means the vertex is representing a minimum. Right, so in this case, it's a minimum. If it was an A value that was negative and it was opening down, then the vertex is the top, so it would be a maximum. But in this case, the minimum value is negative 9. It's the y-coordinate of the vertex. You could say that it's a minimum value of negative 9 at an x value of negative 2. Okay. And again, if you want to do the rest of the steps to graph, it's just the same as what we've already done. So same question here. Why don't you try to find the minimum or the maximum on your own first, and then we can come back and compare. So pause it here, try it, and then come back. All right, so again, I'm just going to use the same formula. X is equal to the opposite of b over 2a. In this case, b is negative, well, b is 2, so the opposite of that would be negative 2. A is negative 1/4, so 2 times negative 1/4 will go in the denominator. You end up with negative 2 over 2 times negative 1/4 is negative 1/2. Negative 2 divided by negative 1/2 is like saying negative 2 times negative 2, so the answer would be 4. So the axis of symmetry would be going through 4. In order to find the vertex, we're going to substitute that 4 in. So you have negative 1/4 times 4 squared is 2 times 4 minus 3. 4 squared is 16. 16 times negative 1/4 is negative 4. 2 times 4 is 8 minus 3. Negative 4 plus 8 is 4 minus 3 is 1. So your vertex is at 4, 1. This one will open down because the a value is negative. So it has a maximum value at 1. Or a maximum value of 1, and it's at an x value of 4. And again, if you want to graph the rest of the function, you could do that. All right, last question. We're going to put that skill into context. So any kind of word problem where you're being asked to maximize or minimize something, in this case, it's a maximizing revenue question. You're just going to find the vertex of whatever the function would have been, okay? So company is selling vacation packages. They want to know what price they can set it at that's going to maximize their revenue. So the price is defined as P. The number of packages sold is defined as the expression there. The revenue is the amount of things you sell for how much you sell them for. So we're going to multiply them together. So we're just going to distribute the P in there. So revenue is equal to negative 0.12 P squared plus 60P. All right, keep in mind that is going to be an A value. That one's the B value because it's the linear term. There is no C value here, and that's okay because I'm not going to need it to answer this question because the only thing I need to do to answer well, there's two questions, right? What price will maximize revenue? That's like the x-coordinate of your vertex, or in this case, P. Just changing a different letter, but it's the x value that we've been working with. And then what is the maximum revenue? That's like your y value, your y coordinate of the vertex. In this case, it's the r. So we're just going to use the same formula. So in this case, the p value of the vertex, which is typically like our x, right, is the opposite of b over 2a. This is going to be the answer to the first question. So in this case, b is 60, so the opposite would be negative 60. A is negative 12 hundredths, so 2 times that is going to go in the denominator. So you end up with negative 60 over negative 24 hundredths. I'm just going to pull out my calculator and do that. So negative 60 divided by negative 24 hundredths, and you get 250. So the price that maximizes revenue is $250. The revenue that they're going to generate by setting that price, we're going to find by substituting that 250 in for P in the function that we found. All right, and then when we do that, you generate $7,500 of revenue. So again, your answers to the question are the price that will maximize revenue is $250. The maximum revenue will be $7,500. This is a very typical type of question that you might see on an SAT, on a PSAT. Again, file this away in the back of your mind. If you get a question that is asking you, and it gives you a quadratic function or a way to find a quadratic function, and it's asking you to maximize or minimize, that is simply code for find the vertex. The vertex is going to be your answer. Okay. So that's it. The exit ticket will be posted, and when you give that a try, we'll go over all this on Monday. In class, we'll go over the exit ticket together on Monday, and then the practice for this, you're not going to worry about until Monday. All right. Let me know if you have any questions.